Dear students, now after learning about the Newton's second law of motion, which states that the rate of change of momentum is equal to the unbalanced force acting on any body. That means the rate of change of momentum is equal to total change in momentum upon the time taken. So knowing about it, let us see and peruse through this numerical based on the change in momentum, which is a car weighing 1500 kg moving with a velocity of 60 km per hour retards uniformly to rest in 20 seconds. This time I have not pasted any figure, so you have to imagine that a car has a 1500 kg mass, okay, and it is traveling with a velocity of 60 km per hour, retards uniformly to rest in 20 seconds, okay, and we have to find the change in momentum that takes place in 1 second. Now students, see, first of all we write the given data in the numerical, that is the mass of the car is 1500 kg and the car is moving with a velocity of 60 km per hour. That means the initial velocity of the car will be 60 km per hour, okay. Then we will talk about the conversion of the units afterwards. Then it is retarding uniformly to rest. That means the car is retarding to rest. So in this way we can understand that the final velocity of the car will be approximately to 0 km per hour, okay, because the car is retarding uniformly. That means acceleration is constant, okay. There is uniform acceleration because of which the car is retarding uniformly to rest. So in this way the final velocity of the car will come out to be as 0 km per hour and in 20 seconds. The time taken to retard for the car is 20 seconds. Now they are asking, find the change in momentum that takes place in 1 second. Okay, first of all let's find out the change in momentum. As we know, the formula for momentum is mass into velocity, okay. So the total change in momentum will be final momentum minus initial momentum, okay. So the final momentum will be the 1500 kg mass. Before that, let's convert the unit of the initial velocity, the final velocity, into meter per second, because the unit for momentum is approximately near about is about kg meter per second, okay. So it can't be kg kilometer per hour, it will become absurd, but it should be kg meter per second, as I told you earlier. So to convert the kilometer per hour into meter per second, as I told you in the motion chapter, we multiply by 5 by 18, okay, or 1000 upon 60 into 60 seconds, okay. That means 1000 upon 3600 seconds. So the value for change into kilometer per hour from meter per to meter per second, the 60 will come out to be at 16.667 meter per second. Now the final velocity is 0, so the unit for meter per second also will be 0 only. The value for final velocity of the car will be 0 meter per second. So now students, see, we have find out the change in momentum, that is final momentum minus initial momentum. The final momentum is mv, m is the 1500 kg mass into the velocity is final velocity is 0, and the 1500 into u, that u is 16.67 meter per second. So the 1500 brackets 0 minus 16.67 is the change in velocity, and the value come out to be as for the change in momentum is, that is minus 25,005, okay. Now they are saying that that takes place in 1 second, okay. Now if we divide the value by 20, immediately the change in momentum in 1 second can be calculated. So in this way, minus 25,005 upon 20, the value comes out to be as minus 1250.2 kg meter per second square, and the kg meter per second square, as I told you earlier in the previous slide, that is kg meter per second square is 1 Newton. So this is minus 1250.2 Newton. So students, the minus value indicates that the momentum is decreasing, As I told you earlier, the body is retarding. That means an unbalanced force in the opposite direction is acting. So in this way, the negative sign indicates that the momentum is decreasing, that is, the force applied is in the opposite direction. Okay, students. So this was a related example based on the change in momentum. We will be solving many more numericals based on the force, Newton's second law, in the coming classes, so that you should be able to clearly understand the concept of the numericals and totally grasp the concept about it. So there are few reasoning questions also based on this Newton's second law of motion, that is the change in momentum, rate of change in momentum is equal to unbalanced force. We will be learning about it in the further sections. Thank you, students. Thank you very much. Please note down the numerical very clearly, step by step. Don't skip any steps and write down clearly. Thank you, students.